May 16, 2025. Kentucky believed it was too far east, too settled for a monster tornado. But within an hour, Somerset and London faced winds nearing 170 miles per hour. Neighborhoods erased, forests flattened, lives lost. Yet official warnings had grown louder every day before the storm. Why were so many people still unprepared for what was coming? The answer begins with the habits and blind spots of an entire region. Tornadoes are not supposed to happen here, or at least, not like this. For generations, people in Somerset and London saw tornado warnings as something for the flat fields of Oklahoma or the wide-open plains of the Midwest. In Kentucky, especially this far east, the hills and forests felt like a kind of shield. Most residents could count on one hand the number of times a truly violent tornado had struck within 100 miles. Before May 2025, only 2 EF4 tornadoes had ever been recorded in the state's history, and neither had torn through these counties. That sense of safety shaped how families prepared. Few homes kept more than a single way to get alerts. Maybe a phone app, maybe the old town siren. Battery-powered NOAA weather radios, the gold standard for overnight warnings, were rare in local stores and rarer still on nightstands. Older residents trusted they would hear the siren or a knock from a neighbor if trouble came. Younger families assumed their phones would buzz in time, not realizing that late-night storms often arrive when batteries are low or phones are set to silent. When the power goes out, as it did for over 100,000 Kentuckians that night, those single points of warning vanish. The idea of a monster tornado striking after midnight simply did not fit the local experience. That is why, even as meteorologists raised alarms and official warnings grew more urgent, so many people went to bed on May 16th, believing the odds were still in their favor. Forecast maps rarely draw much attention in Kentucky, but by mid-May 2025, the language coming from the Storm Prediction Center was impossible to ignore. On May 12th, the first hint arrived: a marginal risk, the lowest tier, with a shaded area stretching across the Ohio Valley. The discussion mentioned only a conditional risk for organized severe storms, and most people barely noticed. By the next morning, the outlook sharpened. The slight risk zone expanded, now covering a broad sweep of central Kentucky, including the Somerset-London corridor. Forecasters warned that all severe hazards were possible and that tornado potential was increasing. 2 days out, the tone changed again. The enhanced risk upgrade appeared, with meteorologists citing robust photographs and supportive CAPE, technical terms that, to those who follow storm science, meant the ingredients for powerful tornadoes were falling into place. The public outlook highlighted the threat for long-lived supercells and urged heightened vigilance, especially after dark. On May 15th, the morning update brought a moderate risk. Somerset and London now sat at the heart of the highest concern. The bulletin called for rare, potentially significant severe storm risk, with the possibility of strong, long-track tornadoes. Emergency managers received direct briefings, and local officials were urged to review severe weather plans. By the morning of May 16th, confidence was high. The midday update warned of at least one strong, possibly violent, long-tracked supercell developing that evening. Mesoscale discussions issued just hours before the storm called for immediate readiness, emphasizing the risk of nocturnal tornadoes and the urgent need for the public to take all warnings seriously. Through each update, the official language grew more urgent. What began as a distant possibility had become a clearly defined threat, mapped in red and orange across southern Kentucky. For those watching closely, the escalation was unmistakable. Air that night was thick with moisture, far more than usual for mid-May in Kentucky. Dew points hovered in the upper 60s, signaling a deep well of humidity drawn straight from the Gulf of Mexico. This was not just a sticky evening, it was the kind of air that feeds storms, loading the atmosphere with latent energy. As dusk settled, a powerful low-level jet began to ramp up. Winds a mile above the ground screamed out of the southwest at over 50 miles per hour. while surface winds shifted and curved, creating a sharp difference in both speed and direction with height. Meteorologists call this wind shear, and it is the invisible hand that can twist a thunderstorm into a rotating supercell. The parent storm had already traveled hundreds of miles, forming over Missouri and growing stronger as it crossed state lines. High moisture and strong shear worked together, allowing the updraft to tilt and spin, an engine that could run for hours without sputtering out. Normally, storms in this part of Kentucky struggle to last through the night, but this one tapped into a persistent flow of warm, unstable air, and the cap, a layer that sometimes holds storms back, was weak or absent. Nothing stood in the way. With these ingredients in place, the storm structure became textbook: a deep, rotating updraft, a broad inflow of humid air, and a downdraft that wrapped rain and hail around the core. Radar scans picked up a classic hook echo, while dual polarization signatures hinted at debris already being lofted into the sky. The atmosphere had set the table for a long-lived, violent tornado, one that would not weaken as darkness fell. Just after 11 p.m., the tornado made contact with the outskirts of Somerset. It didn't roar in and vanish. It dug in and stayed. The initial touchdown barely gave time for sirens or cell phones to sound before power lines snapped and transformers burst blue against the night. In minutes, the storm's rotation tightened, pulling debris from the ground and sending it spinning into the darkness. This was not a brief, skipping twister. Meteorologists would later confirm the track. Over 60 miles of continuous destruction, nearly an hour and a half with the vortex on the ground. Violent winds inside the core reached an estimated 170 miles per hour. That's enough to strip bark from trees, twist steel beams, and hurl vehicles across fields. Chasers and emergency crews reported seeing not just one funnel, but a churning mass, multiple vortices, each one a tornado in its own right, orbiting the parent circulation. Radar scans showed a classic debris ball, with objects lofted thousands of feet above the hills. In the Daniel Boone National Forest, the tornado carved a scar so wide that satellite imagery would later reveal a brown path through what had been solid green. Timber snapped and splintered, leaving only stubs where trees once stood. Towns along the path, Popularville, Sunshine Hills, and the western edge of London, felt the full force as the tornado intensified, tearing through homes and businesses in the dead of night. Long-track, violent tornadoes like this are rare anywhere, but in Kentucky they are almost unheard of. Most storms here fall apart after a few miles. On this night, nothing stopped the Somerset-London tornado. Its endurance, its relentless power, and its timing after midnight turned a dangerous storm into a historic catastrophe. Entire neighborhoods in Somerset vanished in the space of minutes, reduced to bare slabs and tangled piles of lumber. The Sunshine Hills subdivision in London, once a grid of quiet streets and tidy homes, was leveled, block after block swept clean, with only fragments left to hint at what stood before. Metal warehouses near the highway were stripped to their steel skeletons, their walls scattered across fields. In the Daniel Boone National Forest, the tornado carved a mile-wide scar through 30,000 acres of timber. Stands of mature pine and oak, some over 80 years old, were flattened or snapped to stubs. Surveyors found whole hillsides denuded, with root plates torn from the soil and bark ripped away by wind. The scale of loss was difficult to grasp. A landscape transformed overnight, both city and forest bearing wounds that would last for years. Sirens fell silent as power lines snapped, and cell towers blinked out one after another. In the darkness, many never heard a single warning. 20 lives were lost, most in London, and 108 people were injured before the sun rose. Yet even as the system faltered, neighbors became rescuers. People with working phones spread the word, while others went door to door, pulling survivors from collapsed homes. Somerset High School's gym turned into a relief hub within hours, run by volunteers and teachers. The failures spurred action. By summer, Kentucky committed millions to siren upgrades, new battery backups, and statewide emergency alert reforms, determined that no community would face the same silence again. Today, Kentucky's upgraded alert systems stand as proof. Even rare disasters rewrite the rules. Tornadoes like this are no longer unthinkable here. As the atmosphere grows more unpredictable, the next warning is not just possible, it is inevitable. The map has changed. Our readiness must change with it.